Welcome to today's lesson on intersecting chord angle theorem. My name is Mr. Giovanelli, and this is Agua Fria High School Distance Learning. All right, here's your learning target for today. We're going to learn how to calculate the measure of angles formed by the intersection of two chords in a circle. All right, and this is one of the many theorems that's in this big standard about angles and lines formed in circles. So this is just one of the many theorems that we're going to focus on. All right, let's review really quickly what you've already learned. So you've already learned that central angles, that's an angle that's formed with the center of the circle, they have the same measure as the arc that they intercept. So this angle, this central angle, forms this arc. These two have the same exact measure. So that's something you've already learned. And then related to that, inscribed angles, this is an inscribed angle. These angles have half the measure of their intercepted arc. So whereas the central angle would have the same measure, angle x here would equal half of 82, which is 41 degrees. So that's a review of what you've already learned. Now let's look at a new case. This situation here doesn't meet either of those conditions. The center of this circle is O, so this is not a central angle. It's also not an inscribed angle because it's not touching the outside part of the circle here. So it doesn't meet either of those conditions. So we need to learn a new theorem to figure this one out. To teach this theorem, I like to always go back to using a central angle because I think it's a good way to remember it. So let's imagine we had a central angle P right here, and as you can see, it's 90 degrees, right? So that means this arc here, arc QS, is also 90 degrees. So let's look what happens if, let's extend these two lines. So I've made two diameters of the circle. So that means this is 90. So that means this is 92. So let's imagine something. If we accept that these two are 90, let's imagine that we were trying to figure out what that angle was. You'll notice that if you take 90 plus 90 and divide it by 2, you'll get 180 divided by 2, which is 90. So what I wanted to show you there is that this angle here is going to be the average. Let's try that again. It's going to be the average of the two arcs. And remember, this works because even though this is called the intersecting chord angle theorem, the diameter is a chord. So if it works with the diameter is a chord, it works with all the chords. So let's go back to this problem. Now that we know that this angle here is going to be the average of the two arc measures, we can figure out what x equals using this simple equation. Averaging something is just adding them together and then dividing by the number of things you added. So since we added two things, we're going to divide by 2. So we're going to say 32 plus 54, that's going to be 86. Divide that by 2, so angle x is going to equal 43 degrees. All right, if you ever wanted to extend this idea, this would also have to be 43 over here, right? And then you could even find, using angles on the line, you could use other things you know. So like this angle next to it would be 137. So you can start applying a lot of other knowledge, but the intersecting chord angle theorem is this idea here. It's the average of those two lines. All right, this is just something you can take a picture of, put in your notes, but this is another example. So this measure of this angle here, made by the two chords, angle DEC, is 1/2 the measure of arc AB plus arc DC. So they're just saying 1/2 times these two things multiplied together. That's the same thing as dividing by 2. So either way, you'd get the same answer here, which is going to be 82. All right, now that we have an idea how this works, let's try a couple out. As always, I encourage you to follow along, pause the video whenever you need to. So let's figure out angle 1 here. So angle 1 is going to be the average of these two arc measures. So angle 1 is going to equal 102 plus 194 divided by 2. So 102 plus 194, that's going to be 296. And if we cut that in half, that's going to be 148 degrees. So angle 1 in this first problem is 148 degrees. All right, let's try the next one. Same idea. This angle here is going to be the average of these two arc measures. So this angle 1 is going to be 33 plus 131 divided by 2. So that's going to be 164 divided by 2, and 82 is going to be your answer there. All right, let's take it one step further. So notice here now a slightly different situation. Now the intersected chord angle is given. One of the arcs is given, but this other arc is not. So what we're trying to find is this other arc. So we can approach this a couple different ways, but let's start with an equation because that will work anytime. If we just set it up the same way, we know that 115 has to equal 105 plus x divided by 2. Same setup as on the previous slides. The only difference is we have to work some algebra here to isolate this x. So the first thing I'll do here is let's get rid of this division by 2. Let's multiply both sides of this equation by 2. That'll get rid of our fraction. 2 times 115, that's going to be 230 equals 105 plus x. And then if we subtract 105 from both sides, we're going to get x equal to 230 minus 105. That's going to be 125 degrees. Now, a quick way to check our answer, I just want you to compare the answer we got and then the angle in the middle and then this other angle. Notice that 115 is exactly in the middle between these two angles. And that's what we want. It should be a number that's right in the middle of those two arc measures because that's what the average is. Okay, last one we're going to do today. As you can see, we're just adding more algebra, but this is why you want to be able to set up algebraically. If you can set it up algebraically, you can solve any problem. So we're going to start the same way. 132, that's our angle that's being formed by the intersection, is going to be 7x plus 14, that's our first arc, plus 201 divided by 2. All right, let's approach it the same way. Let's multiply by 2 on both sides. Kind of ran out of space over there. 2 divided by 2 is 1. So now we have 264 on our right side. And then we have 7x. Let's combine like terms here with the 14 and the 201. 7x plus 2, 15. All right, let's subtract 215 from both sides. So now we have 7x equals 264 minus 215. That's going to be 49 divided by 7. So our x value here is going to be 49 divided by 7, which is 7. All right, so you notice the concept never changed, just the algebra got a little more advanced as we went, but the same setup was always the same. So to find the angle measurement of an intersecting chord angle, you take the average of the two intercepted arcs. Add them up, divide by 2. All right, that should do it. You should be ready for your exit ticket. Good luck.